How diddly doodly do? How are we doing? We are back for our second video for the January 2017 Algebra 2 Common Core exam. We will do problems 9 through 16. Let's get started on this beautiful, beautiful, beautiful day, shall we? So, welcome to number 9. This is a data and stats problem. And I like to deem this problem the worst problem I have ever seen put on an Algebra 2 exam. I don't like it. It kind of, to me, makes not a lot of sense. And it's horrid. Okay? So let's just get through it. Gabriel performed an experiment to see if planting 13 tomato plants in black plastic mulch leads to larger tomatoes than if 13 plants that are planted without mulch. He observed that the average weight of the tomatoes from tomato plants grown in black plastic mulch was 5 ounces greater than those from the plants that were planted without mulch. Okay, so we have the mulch, and we have no mulch. Okay? And we got tomato plants. Tomatoes. Tomato, however you want to do it. Bang, bang. It's not an apple, it's a tomato. Okay? That'll just give you a visual. Oh, Lord. To determine if the observed differences is statistically significant. To me, this screams, if it's significant, if it's normal, that screams at 95%. That I'm not saying that's under mulch for right now. In fact, we have two things. We have mulch and no mulch, and that to me screams 95%, statistically significant. He randomized the tomato groups 100 times to study these random differences in the mean weights. So what he did is he weighed these. Yeah, IGH. He weighed these and he weighed these, okay? And he wanted to find the mean weights. Excuse me, I'm going down in a blaze of glory with this problem. It's taking me forever to read it. The output of his simulation is summarized in the dot plot below. I love that word, dot plot. All right, so the differences in mean weight in ounces. So the difference between my mulch, the average plant weight for the mulch, and what that was planted in the mulch, and the difference in the weight of the average weight of the plant that was planted without mulch. So this is what we're taking a look at. Now, we're going to go down here, and we have 4 options here. All right, 4 options. Can I get that all on there? Yeah, I can. Given the results from the dot plot, I just had to say it again, what is an appropriate inference that can be drawn? Appropriate doesn't mean it has to be 100% true. That is just a legitimate outcome that you can realize from this dot plot. 1, there was no effect observed between the 2 groups. I don't know if that can be said or not. 2, there was an effect observed that could be due to the random assignment of plants to the group. All right? Maybe. Okay, that's maybe. That's always a possibility. And when you randomly assign plants without any rhyme or reason, I mean, sometimes you get mixed results. There's strong evidence to support the hypothesis that tomato plants planted in the black mulch are larger. And then 4 says that there's strong evidence that the tomatoes that were planted without the mulch are larger. Okay? So if I go back here, he says, and let me highlight this because you know how much I love my highlighter. He observed that the average weight of the tomatoes from the plants grown in the mulch was 5 ounces greater. Okay, so I look down here. If I go to +5, that's halfway right, somewhere around here. That's going to be the +5, all right? I don't know, that's kind of, all right, that was the average. And you can see that this is kind of skewed a little bit more to the right, all right, so there is some sort of effect. So I'm not going to say that number 1 is legitimate, okay? There is an effect, okay? But I can't tell, to be honest with you. There's no strong evidence, okay? To me, there's no strong evidence. And I guess if you want, can we draw a regular bell curve here? Not so much. I think it is definitely skewed a little bit. But there's no strong evidence that the plants with the mulch are larger. And there's no strong evidence. Strong means an overwhelming amount of evidence. I mean, not just like a possibility. There's no strong evidence either way here that the ones in the mulch are bigger or that the ones without the mulch are bigger. So, I mean, the answer is choice 2. That is the legit answer on the answer key. It is choice 2. That's a rough one to get through. I really, you've kind of got to use common sense. I mean, there's always a possibility of having an effect due to randomly assigning plants. If I take plants, I just randomly move them. Maybe some plants are healthier than others, and we just randomly put them in some sort of group without knowing. That is always a possibility. 2 is the answer. I had said that this is the worst problem I've ever seen written in an Algebra 2 exam, and now you know why. Terrible. Let's move on. Let's put it in our past. Oh, thank God, we're back to straight out algebra. All right, so if P of X equals A times B to the X, and R of X equals C times D to the X, then what is P of X times R of X equal? All right, well, let's just multiply them together. If I have A, B to the X times C, D to the X, I'm just going to put everything together. All right, well, it looks like we have some things in parentheses, and something's kind of like taken out of that parentheses. The only thing that shares anything common that I could take out in parentheses are the B and the D. What do they have in common? They have their exponent in X. So I'm going to rewrite this. I'm going to say it's A, C, B to the X, D to the X. All right, here's what they did. That's like saying AC. I can take B and D and raise it to the X. Let's not forget, if something is in parentheses, all right, let's do this. If I have an A and a B and they are both squared, right? If I square them both, I have to apply the square to both of them, don't I? That's like saying A squared and B squared, all right? It's the same thing, these two. So instead of making that a 2, what if they were an X here? Well, it's the same thing as pulling them out and putting an X here. That's how this can become this. And this is our answer, which is choice 3. Not too bad. Confusing when it's like 4 different letters, you know, and then X, which is also another letter variable, but A, B, C, and D are supposed to represent numbers, but I guess a variable does as well. Who cares? We're done with number 10. Number 11, the solution to the equation 18x squared minus 24x plus 87 equals 0 is. Visca, can I use my calculator? Yes. I can take this whole thing. Remember, we have I in the calculator. That is above the decimal point in blue. I can take that and make it equal to x. So I can put that whole value in for this x and this x and hit enter. If it equals 0, that's your answer. If it does not, then you take the next whole thing right here, okay? And you put it in for your x and see if it equals 0. Now be careful. You see how it's a plus or minus? When you put this in for x, there is no plus or minus in the calculator. What that is telling you is that you can use plus or minus because both of those should be an answer. So if you put it in the calculator, pick one. I don't know, pick plus. Put a plus in there first. If it equals 0, that's the answer. If it doesn't, try the next one. Put a plus here, okay? But I am going to show you how to do this algebraically. We're going to use the quadratic formula, which I believe is on the reference sheet, maybe. I think it is. On the right column, like the second or the first thing listed. Blammo! And there it is. This is the reference sheet. And look what we have written here, children. It's the quadratic formula. So I was right. It is in the reference sheet. But dude, back to our problem. All right, we are going to use that quadratic formula. Oh boy, I can't even factor anything out here. I have nothing in common. So my A is 18, my B is negative 24, and my C is 87. So my quadratic formula is the negation of B plus or minus the square root of B squared minus 4AC all over 2A. Let's just put our numbers in, and then we're going to have to do some algebra to simplify, shall we? Okay, so B is negative 24, so I negate a negative 24 plus or minus the square root of B, oh my goodness, which is negative 24 squared minus 4 times A, which is 18, times C, which is 87. Holy smoky dokes. All over 2 times A, which is 18. Wow. Wow. All right, well, let's do this poo-poo. The good thing about this is you see how there's radical 158 here in all of these? That's good. That's going to help us clean up this mess under here. I'm going to tell you that right now. All right? Let's just go ahead and start this. So let's simplify. If I negate a negative 24, that turns to positive 24, plus or minus. Let's take this whole thing. Forget the radical. Whatever's under the radical, let's just put it in the calculator and get one number. I should get a negative value because I'm going to end up with an imaginary number, an I. And an I comes whenever we have a negative under the radical. So let's do this. There it is. Oh, I love this time when I get to hit clear. There we go. The calculator's already on, and we have parenthesis negative 24 squared minus 4 times 18 times 87. All right, now look it. I typed it in just as I had here, parentheses and all. I hit enter. I get negative 5688. Okay, negative 5688 all over 2 times 18, which is 36. Okay, now let's bring this up here. I've got 24 plus or minus. Okay. The negative pops out and becomes an I. Square root of 5688 all over 36. Now, I'm going to try and find the biggest perfect square that goes into 5688. Okay, I've got to, kind of reduce this radical. One of those, okay, when I factor this, one of the factors is going to be 158. So 5688 actually equals something times 158. Okay, let's figure out what that is in the calculator. All right, so I'm going to take 5688 and divide it by 158. I get 36. Oh, that works out perfect. So I have 24 plus or minus I times radical 36, radical 158. Because when I multiply these two, I get radical 5688. Okay? See, that's where that 158, that actually helps me. All right? All over 36. Well, I know what the square root of 36 is. It's 6. All right? So we have 24 plus or minus 6I, because 6 times I is 6I, radical 158 all over 36. Okay. Do you see what they do here? They broke this down into 2 terms. Okay? So I'm going to have to split up my fraction by the plus or minus. So what does that mean? I'm going to go a little bit further down here. It's a lot of work for a multiple choice problem. I got 24 over 36 plus or minus 6I radical 158 over 36. And now I can just reduce these fractions. Well, it looks like 8 goes into here 3 times, and 8 goes into here. Did I say 8? 12. I'll be okay. 12 goes into here twice, and 12 goes into here 3 times. So I've got 2/3 plus or minus. 6 goes into here once and goes into here 6 times. So I have 1/6. I have my I and my radical 158. So which answer has a 2/3 plus or minus 1/6 I? Whew, that was a lot of work. They didn't let us off easy there. A lot of algebra work. All right, Visca, there's no way I would have done that. Then you take the time to enter these in the calculator, each one of these individually, and put them in for X and see what you get. I know you're going to try and leave after 2 hours, so take the extra, what? This would have taken an extra 2 minutes to type all this in? Take the extra 2 minutes to get the answer right. Okay? Number 12, algebra. This is a straight out calculator problem because they tell you to do the calculator. They tell you to use a calculator. When g of x, which is 2 over x plus 2, and h of x, which is the log of x plus 1 plus 3, are graphed on the same set of axes, which coordinates best approximate their point of intersection? Graph these two and see where they intersect, okay? Now they're rounded to the 10th, so you're probably going to have to round to the 10th yourself, okay? So let's just go ahead and do this. Let's clear this, go to y equals, clear this, and clear this, and clear this. And we're going to come up here, and we are going to start by putting in g of x. That is 2 divided by, put this in parentheses, x plus 2. That's my first one. The second one, let's go over here, which is h of x, is log of x plus 1, parenthesis, plus 3. If I graph these two, is my window just a 10 by 10? Yes, it is. Keep in mind, see all my answers are technically the biggest x or y value I have. My biggest y value is 3.4 or 3.3, and my biggest x value is 1.4. I can technically zoom into that area. But first, let's look at it on a 10 by 10 screen. If I graph this, there's the first one because it's 2 lines. There's the second one. It looks like it right there. See where I'm pointing there, that circle? That's where it intersects. So let's do a zoom box. Oh, I love the zoom box. Zoom box is my first one. I get to draw a box. See my little dude here? I'm moving him here. I'm going to go, the intersection's here. So I'll start here. Once I hit enter, notice that little, mark is going to turn into a rectangle. And then I'm going to move that rectangle up, and now there's lines. I'm actually going to create a rectangle where I move, and that's what it's going to zoom in on. Hit enter. Bam. Okay, that's the fraction, my y one, right there. That's the intersection. I know that's negative, almost -1, right? So my x isn't going to be 1.4. My x is going to be one of these. Now, the only difference is it's probably going to be rounding, how I round this on my y value. So how do we get the point of intersection? Second, calc, intersect, number 5. And I move the little bug dude closer to the intersection, and I hit enter 3 times. Now look at, you see how I just moved him there? He looks like he's right on there. Don't assume that's 1.9. Okay, that's really close. But if I really want the intersection point, I can't just trace. I need to hit enter 3 times. If the intersection point happens to be, okay, -0.92 is my x value. and my y value is 1.86. That happens to round up to 1.9. This will round down to negative 0.9. Choice 2. That was a real, man, after having a couple difficult problems, that was real easy. 13, this falls under miscellaneous, but this is another easy problem. The price of postage stamps in the years since the end of World War I is shown in the scatter plot below. I still like dot plot. Anyways, there we go. Beautiful. There it is. Which equation, here, which equation best models the price in cents of the postage stamp based on this data here that we have here in this? Now look at, if I were to follow this kind of like a line, it would go like this and kind of go up a line of best fit, right? This is a sine curve. The sine curve is an S. It's not that, okay? This is the graph of a straight line. It is not that. This is an exponential, meaning that the variable is the exponent. It is either this one or it is either this one, all right? How do I do that? Graph both 2 and 3 in the calculator and see which one most looks like this. Now, please be careful. When you graph it in the calculator, your x-axis should go from 0 to 100 by 20s. Graph the same window that they give you, okay, if you truly want to get the best view, all right? Your y values should go from negative 10 to 60 by 10s, okay? So we're going to go ahead and do that right now. I'm going to go here. I'm going to go to y equals. I'm going to clear these out. Clear. And I'm going to put, let's start with number 3. I do 1.43 times 1.04 raised to the x. Now, I want to change my window. It doesn't matter if I put it in y2, as long as I put it in one of these y slots. My window, my x's, again, should go from 0 to 100. So I'm going to go from 0 to 100, and I'm going to go by 20s. That's what that x scale means. How often I want to see my tick marks. My y is going to go from negative 10 all the way up to 60, and that scale is going to be by 10s. Why do I do that? Because that's what they give me. That's how I'm seeing these plots. So now if I graph this, oh, that's nice. That's nice. That's the answer. So let me do this. Bam. If I put this here, and I come all the way out to here, it's kind of close, right to there. And I do what I like to do. Okay, I do this, and I go to properties, and I try to slide this out. You see how that, look at that. That line, that dark line, it follows almost exactly. That is perfect. So look at that. That is great. That's our answer. This one, for the sake of time, if I graphed it, I think would go steeper. If I were to graph it in red, it would go steeper like this. So if you graph it in a 10 by 10 window, it might look the same, but you need to change your window to what they give you. It's not that one. It is choice 3. Number 14. The 8th and the 10th terms of a sequence are 64 and 100. If the sequence is either arithmetic or geometric, it can be either one, the 9th term cannot be. 3 of these terms, either 1, 2, 3, or 4, either negative 82, negative 80, 80, or 82. 3 of those numbers can actually be the 9th term in the sequence between 64 and 100, either arithmetic or geometric. Right? One of them cannot work for either one. All right, so let's go. Arithmetic. Let's start with the easy one. Arithmetic. All right? Yeah. Here we go. Arithmetic, I add. Okay, remember, arithmetic goes up by the same amount. Like it goes up by 4 every time. Like I keep on adding 4, adding 4, adding 4. So let's take a look at the number 80. If I have 64 as my 8th term, and I have 100, yeah, I was about to put 80 there. Let's put 100 here, all right, as my 10th term. What term can go here? Okay, let's figure out. Let's try actually 82. If I put 82 here, let's just try this one. I would have to add 18 to get to 82, which means I got to keep on adding the same amount. If I add 18 to 82, all right, it gets me to 100. So 82 works. All right, can I add 80? All right, so let me try the same thing, arithmetic with 80. If I have 64 and I go to 80, can 80 be my 9th term in between? Why do I keep on putting an 8 there? This would add 16, right? Which means if I go here, do I add 16? No, I would have to add 20. That would not be geometric. This does not work for arithmetic. This might not be the one that works. All right? So let's try geometric, okay? Let's see if 80 actually works in geometric, because it can be either one, right? So now for geometric. Geometric means I multiply by the same amount. Okay, I multiply by the same amount every time. So geometric would be like if I have 2 and I multiply by 2, I get to 4. I multiply by 2 again, I get to 8, 16, and so forth. You are not adding. You have a common factor. So let's do 64. Can I go to 80, then 100? I keep on putting an 8 there. This is what I'm trying to check for my middle term. So the $1,000,000 question is, how do I get from 64 to 80? Well, I would multiply by 80 over 64. Let me explain that real quick. If I have 64, I multiply by what? We'll call it x to get to 80, right? So how do I solve for x? Divide by 64. Okay, again, I'll show you one more. How do I know this is the answer? If I have 64 and I multiply by 80 over 64, what do I get? Well, the 64s cancel. I get my 80. All right? So that's how I know. That's how I know I multiply 64 by 80 over 64. All right? So in my mind, I say, well, if I want to get rid of the 64, I multiply 64 by something over 64, so it'll cancel. What's left on top will give me my answer, 80. So let's see if that holds true. I multiply 64 by 80 over 64, it gives me 80. I would have to multiply 80 by the same thing to get to 100. Let's see if this works, okay? Calculator. First off, on, there it is. Let's take 64 and multiply it by 80 over 64. That should give me 80, and it does. Now let's take 80 and multiply it by 80 over 64. Does that give me 100? It does. Holy poop schnickel, it works. Okay, so 80 actually works. Because remember, it has to work in either one or the other. Wow, look at us go. Let's keep on working. All right, so now it's either negative 82 or negative 80. All right, first of all, I know that those should never work in this arithmetic sequence. How come? Because if I make this negative 82, I would have to literally add a negative, oh my God, 64 and 82, 6, 146. If I add another negative to a negative, I won't go back to positive. So neither of these will work for arithmetic. Okay, no, it doesn't work for arithmetic. So I'm going to check both of these for geometric. Guess what? I already know that 80 works, negative 80. How come? If I make this negative, what do I multiply 64 by to make it negative? All I got to do is negate this. And now a positive times a negative gives me a negative. If this is negative, this should be the same thing. Now I multiply a negative times a negative, and I get my positive 100. 80 works. Negative 82 will not work. Wow, that was a lot. I should have started with 1 instead of 4 there. 15. The loudness of a sound is measured in units called decibels. These units are measured by first assigning an intensity, I of O, to a very soft sound that is called the threshold sound. The sound to be measured is assigned an intensity, I, and the decibel rating, D, for this sound is found by using this. D equals 10 times the log of I over IO, sub O. The threshold sound audible to the average person is this, 10 times 1, 1 times 10 to the negative 12 watts per square meter. Consider the following levels of classification. Moderate, loud, very loud, and deafening. They all fall under these decibels. Okay, so depending on what your decibel is, let's say you get 50 decibels as your sound, that is in this range right here, that is considered moderate. So what they're saying is, how would a sound with an intensity of 6.3 times 10 to the negative 3 be classified? How do we find decibels? This is a large paragraph for something that is very easy. All right? The decibel rating is this right here. So how do I find my number? I find my decibels by taking 10 times the log of I over I sub O. All I need to do is figure out what goes here and here. All right? Well, what do they give me in the problem? Intensity is this, 6.3 times 10 to the negative 3. Intensity is your I. That value in the problem goes in for my I. So my decibel rating is going to be 10 times the log of I, which is this, 6.3 times 10 to the negative 3, all over I sub O. Do they give me what I sub O is? Okay, I sub O is a very soft sound called the threshold sound. Where is our threshold sound? The threshold sound is this right here. This is I sub O, okay? And this is I. You literally just had to take those and put them here and here and hit enter in the calculator. That is a very, very complicated paragraph to tell you to just plug in two numbers and hit enter. Okay, so let's do that. At the bottom, it's our I sub O, which is 1.0 times 10 to the negative 12. I am literally going to put this in the calculator and hit enter. If you get past all this mumbo jumbo and words, there we go. It's really a simple problem. You just got to get through all this reading. 10 times the log, and I got a fraction here. And I'm going to type it just like it is there. 6.3 times 10 to the raised to the negative 3. That should be negative 3. All over 1.0 times 10 raised to the negative 12. Pop out of here, parenthesize it. Okay, I'm going to pop out, then parenthesize it. Bang. 97.99. 97.99 falls in between this right here. It is considered very loud, which is choice 3. God, you know, sometimes I wish we just have problems again where we could just, there isn't all this setup of scenario. Okay, I feel like sometimes it pulls away from the math, but this is application, and this is what Common Core does. Thank you so much, United States government. Number 16, algebra, a million times easier. Pedro and Bobby each own an ant farm. Pedro starts with 100 ants and says his farm grows exponentially at a rate of 15% per month. Bobby starts with 350 ants and says his farm is steadily decreasing by 5 ants per month. Assuming that both boys are accurate in their description of population of their ant farms, after how many months, we are finding months, will they both approximately have the same? I need to come up with an equation for Pedro and an equation for Bobby set them equal, and figure out what value of m makes them the same. Okay, so let's do this. Pedro. Okay, that is exponential. And exponential is a 1 plus r times time. Our time is months. He starts with 100. That's our initial. He grows by 15%. 1 plus 0.15. M is months. We'll call that M. Pedro, very good. Bobby, B. Okay, his is linear. Okay, his is linear. All right, so his starting linear is mx plus b. This is the y-intercept of the starting value. Okay, he is going to start with 350 ants. All right, months is going to be our variable. This is slope. Okay, months is going to be our time. I know I'm using m there, but how is that decrease? It's decreasing by 5 ants per month. So my slope is -5. It is going down -5 every month. So after 1 month, -5 times 1, I'd lose 5 ants. After 2 months, -5 times 2, I'd lose 10 ants, and so forth, okay? So I'm going to take that, and I'm going to decrease 350 by this amount all the time. All I got to do is set these equal in the calculator. Look, it's one of these numbers. I can technically plug those numbers into both of those m's and see which would give me the closest value. Well, why do that? Let's just put it in the calculator. Okay. And how do I know what the solution is to two graphs or equations when I put this in the calculator? It's where they intersect. So let's go down here, clear this bad boy out. I thought I cleared that bad boy out. Let's put in Pedro here. It's 100 times 1 plus 0.15, boom, raised to the x. Very good, very good, very good. The next one is -5x plus 350. Let's graph this, and we probably aren't going to see the intersection point because our window is still messed up. So what I'm going to do is I'm going to change, oh, there's one of them. I'm going to change zoom to say zoom fit. That tries to get all of the relevant visuals of the graph in the screen. And for this case, it's probably going to get the intersection, I'm hoping. Let's hit enter. Oh, change. This spinning means it's changing. Spin, 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 spin. There you go. Where's my first graph? Where is it? I don't see it. Oh, my goodness gracious. There's one. Oh, wow. Let's go to our window. We're going to have to play it. Wow, look at this max. Are you kidding me? Let's change that max to, I know it's going to go as high as 350. Let's just call that 500. Let's try that. Boom. There it is. Okay. That max was like 100 million. That was crazy. Sometimes you got to play around with that. Here's the intersection point. Okay. Let's see where this is. You know it couldn't be more than 36. All right. My x value is what I'm trying to find where they intersect. You know, on the x-axis, I really didn't have to go farther than 36. I could have went to 40, but it's right here. Let's do second calc intersect, which is 5. And where the hell is my curvy dude? He's at 61 on the x-axis. Let's bring him all the way. Wait for it. Wait for it. There he is. I'm going to hit enter 3 times. Bang, bang, bang. 8.08. So approximately how many months? That's closest to 8. And our answer is choice 2. This is a complicated set of questions, 9 to 16. Complicated set of questions. But we're done with them. And thank God, because I got to teach class right now. Jeez. Stick around. Hopefully video 3, which is 17 through 24, maybe. Maybe that won't be so bad. All right? But now you know. Keep studying. You got this.